Imagine you're sitting somewhere completely normal, a room, a street, a bus, a bed. Nothing dramatic, nothing unusual. And then, without warning, for exactly 1 second, Earth stops, spinning. Not slows down, not drifts, not fathers. A full, instant stop. And 1 second later, it resumes like nothing ever happened. At first, it sounds harmless. 1 second is nothing, right? But the problem is not the time. The problem is speed. Right now, as you're reading this, you are moving with Earth at incredible velocity. If you're near the equator, that speed is about 1,670 kilometers per hour. Even in Europe, where the rotation effect is lower, you're still moving over 1,000 kilometers per hour simply because the planet is spinning beneath you. You don't feel it because everything around you is moving with you. The air, the ground, the oceans, the buildings, the cars, even the dust in the atmosphere, all share the same motion. There is no relative difference, so your body has no reason to register it. But the moment Earth stops, that agreement between everything breaks instantly. The ground stops first. You don't. The atmosphere doesn't. The oceans don't. Everything that was moving keeps moving at full rotational speed, suddenly detached from the planet beneath it. From your perspective, it wouldn't feel like stopping at all. It would feel like the entire planet underneath you has been ripped away sideways at supersonic speed. Everything unanchored becomes a projectile instantly. Cars don't just slide, they launch. Loose structures don't fall, they scatter. Trees snap as their roots are violently torn through soil that suddenly behaves like it's been hit by a planetary-scale earthquake. People outdoors would be thrown eastward at speeds comparable to jet aircraft, except there is no aircraft, no control, no protection, just momentum. Even reinforced buildings, designed for storms and seismic activity, were never designed for the entire planet to suddenly lose its rotational reference frame. And this is only the beginning, because above everything on the surface, there is something else that refuses to stop. The atmosphere. Earth's air is not still. It is locked into the planet's rotation. When the ground stops, the atmosphere continues moving at full speed. What follows is not a windstorm in the traditional sense. It is a global atmospheric shear event, a planet-wide wall of air moving independently from the surface. Wind speeds would likely exceed 1,000 to 1,600 kilometers per hour in many regions. That's far beyond the strongest tornado ever recorded on Earth. And unlike a tornado, this isn't localized. It wraps around the entire planet. Forests would flatten in seconds. Entire ecosystems would be stripped down to bare ground. Glass would shatter across continents as pressure differences spike violently. Even mountains would not protect regions from the atmospheric chaos sweeping across them. Buildings that survive earthquakes might still fail here because they were never designed for a scenario where the entire atmosphere continues moving independently of the surface. But the air is not even the most massive moving system. That belongs to the oceans. Water has inertia, a lot of it. When Earth stops, the oceans continue their motion eastward. Trillions of tons of seawater do not simply pause. They surge forward, carrying all that momentum directly into continents that are suddenly stationary. The result is catastrophic. Mega-tsunamis form instantly, not from a single wave, but from entire oceanic systems collapsing into moving walls of water. Coastlines are erased. Entire cities near sea level vanish beneath walls of water that behave less like waves and more like moving vertical oceans. In some regions, the water would travel far inland, reshaping geography in minutes. Places that have existed for centuries could be completely unrecognizable after just 1 second of planetary stillness. And while all of this is happening on the surface, something deeper begins reacting too. Earth itself is not perfectly rigid. It is slightly wider at the equator due to its rotation. That bulge exists because spinning creates outward force that reshapes the planet over millions of years. Remove the spin, even temporarily, and that balance is disrupted. The planet doesn't instantly reshape, but it begins a violent process of readjustment. Pressure systems in the crust shift. Fault lines respond. Stress that was evenly distributed begins concentrating in new ways. This triggers global seismic activity. Earthquakes ripple across multiple regions. Volcanic systems, already sensitive to pressure changes, become more active as the internal balance of the planet is disturbed. It would not be a single disaster. It would be a cascading chain of geological reactions that continue long after the 1-second event ends. But the most terrifying part is not the stop itself. It is what comes after. Because after 1 second, Earth starts spinning again. And it does not ease back into motion. It snaps. The surface suddenly accelerates back to over 1,000 kilometers per hour. Everything that survived the first interruption is hit again by a second, equally violent global shock. Air masses shift direction again. Oceans surge in new chaotic patterns. Debris that was still airborne or suspended is thrown into new trajectories. Structures already weakened face a second wave of planetary-scale stress. In many ways, the restart is worse than the stop because everything that remained unstable is now forced to adjust again in the opposite direction. At that point, the surface of the planet becomes almost unrecognizable. But there is a reason this scenario remains purely theoretical. The energy required to stop Earth's rotation is beyond anything physically achievable by humanity, or even by most cosmic events we know of. To halt the planet would require more energy than everything humanity has ever produced combined, multiplied by an enormous margin. No asteroid impact, no explosion, no natural force we understand comes close to that scale of influence on planetary rotation. Physics itself resists this outcome. And that resistance is not just mathematical, it is protective. Because Earth's rotation is part of what stabilizes climate, weather systems, oceans, and life itself, it is one of the quiet mechanisms that makes long-term survival possible. We live on a planet that is constantly moving, yet perfectly balanced in ways we rarely think about. A system so stable that we forget it is even in motion. So, when you imagine Earth stopping for just 1 second, what you are really imagining is not a moment of silence. It is the collapse of an entire system that keeps us alive without us ever noticing. And maybe that is the strangest part of all. Not that Earth could stop, but that it never does. And if you enjoyed exploring ideas like this, or if your mind ever drifts into these kinds of "what if the universe broke for a moment" thoughts, leave a comment down below, because there are still so many questions waiting to be asked.